Hey folks, how's it going? It's Mr. Murray coming to you with a Do Now video for Course 1 CP for Monday, June 1st, 2020. And welcome to June, folks. So we're closing in on the end of the year, and we are looking at our last unit here in Course 1 CP, and I'm excited to give you some great final content to end the year here. So what I'm going to be asking you to do is I'm going to be asking you, as I've been asking for the past few days, to do a couple things. First, I'm going to be asking you to convert this first thing here to standard form, and that's -4 in parentheses j minus 12 squared plus 3. And then I'm going to be asking you to convert into intercept form these three things here. These and similar examples can be found at expand.willnot.fail and factor.willnot.fail, two websites that will give you some pretty good mixed practice here. And then, of course, feel free to reach out to me anytime with questions. I remember my open office hours and weekly hangouts. All right, so please take a moment, pause the video, attempt to convert to standard form and intercept form, and then when you're ready, unpause, and you can see what I got. Okay, so this one's in vertex form. So what I'm going to do here is I'm going to start by setting up my box. Boop, boop. So up here I'm going to put my j minus 12. Here I'm going to put my j minus 12. Here we go. So j times j is j squared. -12 times j is -12j. Here's another -12j. And here's a 144. So what I have is -4. I've got to put that in there because it's not 1. J squared, 12, and then -12. That gets me -24j plus 144. Close that out. And then plus 3. Next thing is I do need to distribute here. So I'll distribute that out. -4j squared plus 96j minus. Now 144 times 4. I hope you'll forgive me if I can't necessarily do that off the top of my head, but that's 576. And then I'm going to add 3 to that, and that would be -4j squared plus 96j minus 573. All right, so that's the idea though. You're going to be doing PEMDAS. So you're going to be doing the exponents, then the multiplication, then the addition. Let's not forget our PEMDAS. Parentheses, and the exponents, multiplication, division, addition, subtraction. Here we're not really concerned about parentheses. So first, exponent, then multiply, meaning distribute in, and then add or subtract. Okay? Keep in mind, I've done a number of examples over the past few days. They're on the Google Doc in the video section. I really encourage you to take a look at those because if this is something that you're still struggling with, I'm trying the best I can to provide as many extra work problems as I can for you. All right. Time to convert to intercept form, and so we're going to be going the other way. So I'll start by building out my box. I remember to put my squared term here, my constant here. Now I know I need a c and a c to get a c squared. And now I need to think about how I'm going to multiply to 98. So I've got 2 and 49. I've got, let's see, what else will work with a 98? Let's see, 7? 7 will. Okay. 7. 98. So 7 and actually 14. And that will actually work out perfect. So I know one of them is positive and one of them is negative. These numbers, because a positive times a negative gives me a negative. So I'm going to go -14 and 7. So these add up to -7. So my final answer, c minus 14, c plus 7. Okay. G squared plus 20g plus 100. Seems like the same thing, right? Alright. So we got... So let's try this again. So we got g squared plus 100. So I've got g and g. Now how can I make 100? Well, notice the first thing that comes to mind is 101. But we also have 10 and 10. And as it turns out, yeah. So as it turns out, this is equal to g plus 10 and g plus 10. Or in other words, g plus 10 in parentheses squared. So this is a special case called a perfect square trinomial. It's called that because it's a perfect square. Its factors are two things that are the same. In this case, g plus 10, g plus 10. So it could be represented as a square. In other words, if you could think about if I took its square root, I would get g plus 10. I'd actually get a whole numbered thing, in a sense, you could think about. Okay? And it's called a trinomial because there are 1, 2, 3 things. Last, I'm going to throw at you a little bit more of a challenge here. And let's set this box up. So I've got 4n squared, and I got my 7. Now the trick here is that 4n squared, well, there's a couple ways to get 4, right? It could be 2 and 2 or 4 and 1. The good news is you need a 7 and a 1 to make 7. And they're both going to be positive because I've got a positive and a positive. And so although a positive times a positive and a negative times a negative both give you a positive number, when you multiply, only two positives in this case, if you have to choose between the two, would give you a positive when you added them, right? A negative plus a negative will always give you a negative. So how do we combine these? That's the trick. Well, I know I couldn't do 4 and 7 because that would be 28. And I couldn't do, but I could do 2 and 7. So I'm going to do 2n and 2n. So I get 2n times 1, and this is 14 because it's 2n times 7. So I have 2n plus 7, 2n plus 1. Okay? And so that takes me to the end of that. But the idea is we're about to move on. We are actually moving on to a new unit today. So at this point, you need to be able to expand, convert any quadratic into standard form, especially when a is 1. Now, if a is bigger than 1, -4 is considered a hard problem. If you can't do that, you need to at least be able to expand by doing the square and adding. That's extremely important, okay? Including in intercept form. And then you need to be able to use the box to convert from standard form, as you see here, into intercept form. That's an extremely important skill that you are going to continue to hit on next year. All right, so again, our answers here, -4j squared plus 96j minus 573. And then we've got c minus 14, c plus 7, g plus 10 squared, and 2n plus 7, 2n plus 1. Thank you very much for watching. Best of luck with today's lesson. And remember, you can